Okay, so for this first idea, I'm going to talk about all the parts of a regular pyramid, right? This is the picture of a regular pyramid right here. The reason it's a regular pyramid is because its base is regular. It means it has equal lengths and all angles are congruent. Equal lengths and congruent angles, okay? First things first. This part right here, like one of these faces, so like this front face here, this front face that you see, this is called a lateral face. Okay, a lateral face, that's exactly what you would expect it to be, a lateral face. We have the base down below, and the base in this case is regular, which means that it's a square in this particular case for a pyramid. The height of the pyramid is the height that extends from the very topmost point, which we call the vertex, all the way down to the center of the base. That's the height. It's not what you, I mean, actually it is what you'd think it would be, right? How tall the thing sits. So from the vertex all the way down to the center of the base. All right? Then here's the tricky part. If you take the center of the height here and you draw directly out to one of the bases at a right angle, then what you create on the inside here is a right triangle. Does everyone see the right triangle I'm going to try and highlight for you right now? Do you see the right triangle on the inside of that? It's kind of like inside the actual pyramid itself, okay? That leaves one last piece to talk about, which is this piece that I'm highlighting right here, which they're calling S. This is an important piece. This piece is called the slant height. Okay, the slant height is the hypotenuse of the right triangle inside the pyramid. So that slant height is the height of the, or is the length of the hypotenuse on the inside triangle of that pyramid, okay? And notice that it is perpendicular to the base, okay? So it's perpendicular, it cuts the base in half right there, so perpendicular to the base. You guys with me so far? So theorem 12.4, surface area of a regular pyramid, we have S equals there we go. That didn't work. Okay, everyone have that in their toolkit? Yeah? Okay, good. Let's head back over to ours. And we're going to do an example here. Now we got an area or a surface area of 33.5 on ours. Let's do the same problem, except we're going to do it using theorem 12.4. It says that the surface area has to be B plus 1/2 P times L. Okay? So, what's the area of the base? Did we already figure that out? What was it? It was 12.5 for ours, right? 12.5 plus 1/2. What's the perimeter of the base? Wouldn't it be 3.5 plus 3.5 plus 3.5? So what would that be? What's 3.5 times 4? Okay, let's verify that. We think it's 12.20. Is that right? No. 14? 14. Okay, good. I'm with you. 14. And what is the slant height? Did we calculate the slant height? What was it? I remember correctly, wasn't it 3 inches? Yeah. 3 inches? Okay. Okay, so let's calculate this. S is equal to 12.5 plus, what's 3 times 14? 42. What's half of 42? 20. Oh my gosh. Check that out. 33.5 inches squared. So is the formula hold true to what we did manually on ours? Yes, it absolutely does hold true, okay? So we have a brand new theorem that we're using to find the surface area of prisms, or of pyramids, excuse me. Notice that we got the exact same area by measuring it physically as we did using the theorem, okay? That should get you through everything you need to know for the homework tonight. Any last questions?